Hi, today we're just going to do a quick run through of an alternative method to find critical regions in stats. So normally what you would do is you go into a calculator, go into inverse binomial, and it would give you a round estimate of what your answer would be, then you go and test a couple of values. Now that method is quite clunky, it takes a while, a bit of a time waste in your exam. This method is a bit cleaner, you'll get the answer a bit quicker, it's quite nice. Anyway, so for example, say you had this question in your exam, you probably wouldn't, this doesn't have enough words in, this is just straight maths. Anyway, you've got your null hypothesis, the probability is 0.7, your alternative hypothesis, the probability is less than 0.7, and they want you to find the critical region for a sample size of 20, testing at the 5% significance level to see if you're going to reject this null hypothesis or not. So what you're effectively now trying to find is a region for which there's so you'd have your x, which would be the number of successes within that sample size, and it wants to find a region whereby if x is within that region, you would reject your null hypothesis. So you're trying to find x where p, actually no, as well as a, x is too important. A for which p of x being a is less than or equal to 0.05. Now, I actually did that wrong. You wouldn't want x is equal to a. You actually want to find any value for where x is less than or equal to a, because yeah, basically as you go, it'll be easy to explain once we get there. Anyway, so normally what you do, you go into an inverse binomial, you put in this, it would give you an estimate, you then go test it. Instead, what we're going to use is a table function. So if you get your calculator, you hit menu, you want to go table function, which is 7 for 1, so if you just hit 7, it'll take you straight there. And what you're now going to do, you're going to use the binomial function within the table function to find the values of BCD for a lot of different values of x. So to get up that BCD, you're going to have to hit option, you're going to go along, hit stat, hit distribution, binomial, and BCD, just like you would in a run mode. Give you a minute to get there. So now, what we want to do is we want to have binomial CD, so BCD, and we're testing for less than. So we're trying to find, we want to find this. So what this will now do in the table function is it will find the value of this for a lot of different x. Now to tell your calculator which values of x to do this for, first of all I'm going to put this into my table function. Now, it doesn't know which values of x you want it to use, so to do that you want to hit set, which is F5. You want to start at 0, you want to end at 20 because you've only got 20 in your sample, and you want a step of 1, that means that you'll only get integer values, which is the only values that it can actually find statistical values for. Now, you just want to hit F6, it'll take a little while, and then it will make a big table of different values. Now what this is doing is it's finding BCD of that function that you've put in for all these different values of x. So as you can see, the probability of there being less than or equal to 0 successes in your sample size of 20 is 3.48 times 10 to the negative 11. As you go down, you've got the probability for all 20 possibilities. So less than or equal to 16, it's 0.89, blah blah, so on and so forth. What you're interested in is values where the probability of that many successes, that many or fewer successes, being less than 0.15. That's your significance level. So as you go down, you'll see 8 has 0.5% chance, 9 has 0.01, which is a 1.7% chance, 10 has a 4.8% chance, 11 has an 11% chance. Now, so obviously if you had an 11% chance, that's not within your, that's higher than your significance level, you would not reject your null hypothesis. if you had only 10 successes, it would be a 4% chance. That's less than your significance level. You would then reject your null hypothesis, or well, there would be evidence to reject your null hypothesis. And any value lower than 10, therefore, has a lower probability. So any value of less than 10, any number of successes less than 10, will have a probability of less than 5%. So now you know that A is going to be 10. So effectively now you know the probability of x being less than or equal to 10 is always less than or equal to 0.05. So you know that your critical region is going to be x being less than 10.
Do you want to write that down, Lily?
Of course. So, there we go. Here's our critical region.
Brilliant. Okay.
I'll set up the next example if you want.
Yeah. Keep going.
Can we pause a little the filming?
Okay.
Okay, so here's another example. As you can see, now you're testing for probability greater than. So this is a bit difficult if you're using an inverse binomial because that will only do a BCD of less than something. So you've got to do a bunch of 1 minus or whatever. Anyway, that's irrelevant now that you know this fantastic new method. So for this, you are basically just doing the same thing as last time. If you're testing a BCD in your run mode, you know how you just set up a greater than as being x to your n value and then the rest of it. Anyway, so for this, you're doing the same thing, even though it's normally would be more complicated. So all you want to do is you want to get out your table function, set it up like you had it before, and you want to put in B, C, D of x through to 100, and then your n is 100, and your probability is 0.8. So now, as before, what this will do is it will, for all of your values of x, tell you the probability of any of the number of successes between x and 100, with 100 trials and the probability being 0.8. Now remember before, we went into set and we made it so that it would only go up to 20, so that's all we needed. Now this time, n is now 100. Obviously we need to know all of the values of x being anything from 0 to 100, so you're just going to set, start 0, end 100, step 1, similar to last time. And then you just set up your table with that function in. So all of the very low values have obviously very high proportions because it's very likely that you'll have 0 or more successes. In fact, you know there's going to be 0 or more successes. As you go further down, your probability is decreasing as you go, and you're looking for the point where that probability becomes less than 1% because we're looking for a 1% significance level. So as you go down, 86 has a 0.08% chance. That's not 0.08 chance. That's an 8% chance. Further down, 88 has a 2% chance. 89 has a 1.25% chance. 90 has a 0.5% chance. Now that's finally below your significance level. So now you know that for the probability of x being less than or equal to, wrong sign, greater than or equal to 90 is 0.005. That's a bit smushed in. So yeah, that's less than your significance level. And because as you go further and further down, the thing, so higher and higher values of x, the probability just becomes lower and lower. You know that for any value above 90, your probability is going to be lower than your 1% significance level. So now you know your critical region, the region in which you're going to reject your null hypothesis, is any value above 90. So if x is greater than or equal to 90, you reject null hypothesis as a significant, critical region for this. So now we've got an alternative hypothesis where probability does not equal something. So now this could be greater than or less than. This is very complicated if you're just using inverse binomial. You've got to sort of test both ways, and obviously half the significance level. With table function, you can just put in two different functions and your table will make separate columns for both of those. So if you just want to go there, put up your binomial CD. Now, because your testing does not equal, you've got to test for greater than or less than. So for one of them, you're going to have to put in B, C, D. So if you're testing for less than, you would put in 0 through to X. And then obviously n is 30 and your probability is 0.3. For the other one, you're testing greater than, so you would put in your B, C, D of X is 30, where n is 30. Your probability is 0.3. That's a bit of a mess, but you know what I mean. So now, if you just, you need to set to make sure you'll get the right values of X. So you need to start at 0, you need to end at 30, and your step's going to be 1, obviously 30 because you've got 30 trials. And you just make your table. As you will have seen for your previous tries, even if you put in one function, you'll quite often get 2 columns. One of them is just full of things that say error for this example, because it's trying to, that second column is just trying to differentiate the function. It can't do that if it's stats, because it doesn't know how. So just ignore the y-1 and y-2 columns, or you can get rid of them by going into setup, so shift menu, and then going down to derivative and turning it off, if you want to make your table a bit more compact. So with your first function, you've got your less than. So as you go down, you've got increasing probabilities, and you're looking for one which is just less than 4%. So obviously you want to halve your significance level at the start. So that's going to be 0.04. And by the way, if you aren't amazingly confident with converting between your percentage and your significance level and your decimal, which your table function is going to give you, you can just write it down. You can convert it at the start and write it down, or you could, in your table function, put in your BCD and then times it by 100. That might be a bit more complicated. Probably easier to just convert your percentage into a decimal and then compare that with your table function output. So as you go down your first column, which is this function, when you hit 3, it's about 1%. When you hit 4, it's about 3%. When you hit 5, the probability of it being less than 5 successes is 7%. That's bigger than your half significance level. So for any value of X less than 4, you've got a probability lower than your significance level. So you know that if X is less than or equal to 4, you're going to have to reject that. That's lower than your significance level. Other function, you're looking at greater than. So as you go down, your probability is decreasing. You get to 13, you've got 0.844. 14, you've got exactly, well, it looks like it's exactly 0.04, but then if you look, as you hover over it, in the bottom left of the screen, you've actually got a much longer decimal. That's 0.40052, which is actually greater than 4%. So you're going to have to accept that one, let that one slide, and you're going to have to choose 15 as your first value, less than 4%, being 1.69%. So any value of X greater than 15 has a probability lower than 4%, so that's lower than your significance level. You would then reject your null hypothesis if X was greater than or equal to 15. So there are your 2 critical regions.
Again, we're in table function, and this time we're doing a two-tailed test. Now, the two-tailed test, we're going to do them both at the same time. So the first one I'm going to do is less than. So again, option, arrow, stat, distribution, and binomial. So to do my less than, I'm finding my upper limit. So I've got 0, X, the thing that I'm wanting to find. My value of n is 30. and my probability of a success is 0.3. Execute, and at the same time I'm going to do the upper limit. So again, it's going to be, I'm going to need my BCD. So again, go through those motions again. So BCD, and now it's the lower limit that I want to find because I'm now dealing with the greater than. My upper limit is 30, my value of n is 30, and my probability of a success under the null is 0.3. So I'm now going to go to set, and I'm going to go from 0 to whatever my value of n is, which is 30. My step is 1, and now I'm going to go to my table. So you can see my blue values are my lower limit. Now I'm testing at the 8% level of significance, and because this is two-tailed, that means I half it, so I'm looking for 4%. So I've obviously gone far too far. So we're looking for the first value that's just below 4%. So you can see that your lower critical region is x is less than or equal to 4. And now we're going to go over to look at the upper limit. Remember, we're looking for 4%. So you can see that it looks in the column that it is exactly 4%, but you can see when you look at it accurately on your calculator, it is just above 4%, only just a smidgen above. So our upper critical region is x is greater than or equal to 15. So our critical regions or rejection regions for this question would be x is less than or equal to 4 and x is greater than or equal to 15.